So this is exercise 6D, and for question 4 we just simply asked to differentiate. Now what a lot of students will try and do initially is they'll see that there's 3 parts to this question. They'll differentiate this, then differentiate this, and then differentiate that term. Now remember, the only rule you've learnt so far for differentiation is this: y equals ax to the n, bring the power to the front, and then decrease the power by 1. So we have to make it look like that, and if it's not, then we have to make it look like that. So I can see I've got some parentheses here, so I can certainly distribute here. So x times x is x squared, x times 2 is 2x, 1 times x is x, so 2x plus 1x gives me 3x, 1 times 2 is 2, and then divide by x. Now what I can do now is I can actually split this up. So I can actually say it's x squared over x plus 3x over x plus 2 over x. Now when I come to simplify this, x squared divided by x, subtract the powers, 2 take away 1 is just 1, so x by itself. The x's will cancel here, so I get 3. And 2 over x is just 2 over x. But remember, I want it to say ax to the power of n, so I'm going to rewrite that at this stage. So as it's on the bottom of the fraction, I'm going to give it a negative exponent. So in other words, negative 1. Whoops. Now this is still my initial equation, and all I've done is just write it in a different form. So I might just want to call it y equals at this stage. But now it looks like what I'm used to. Now I can actually go ahead and actually differentiate this. So dy by dx, differential of x is just 1, differential of 3 is 0 because it's a number. And for the last one, bring the power to the front and multiply. So 2 times negative 1 is negative 2. X to the power of negative 2, because you're going to decrease the power by 1. And then if I collect terms here, 1 plus 0 is 1. And the x to the negative 2, that tells me that it's x squared, but it's going to be on the bottom. So in the end, it turned out to be quite a long question, but just make sure you simplify before you start differentiating. Now in question 7, they were actually quite generous to begin with. They gave us the x value, but they also gave us the y value. Now we could have found this y value anyway. The square root of 4 is going to give us positive 2. So we know what our coordinate is. If we're going to write the tangent, we need a point and a slope, so we need to find the slope. So to do that, we're going to differentiate. Now, as that wasn't in the correct form before, I'm going to write it using exponents. And then now I can actually go ahead and I can differentiate this. So bring the power to the front, decrease the power by 1, and we can rewrite this as well. The negative tells us it's on the bottom, the half tells us it's a radical, and we can plug in our value of x to find out what our slope's going to be. So when x equals 4, dy by dx equals 1 over 2 times radical 4. So the square root of 4 is 2, times the other 2 is 4, so in other words, 1/4. Worth reminding you at this point as well, if the question was to say normal, we'd do negative reciprocal at this stage. So flip to get 4 over 1 and make it negative, so negative 4. This one's just tangent, so I got my slope, I got my point. So point slope formula now, y minus y1 equals mx minus x1. And I'm now just going to plug in those numbers. So the y value was 2, the slope we just had was 1/4, and then x minus the x value, which was 4. And it just says find an equation, so technically I could stop at this point. I'm going to multiply by 4 here just to get rid of that fraction. And I'm going to distribute 1 times x is x, 1 times negative 4 is negative 4. And I guess I can bring that to that side as well. So if I add 8 to both sides, I'll get 4y equals x plus 4, or some other form that's appropriate. So this question is very long. It asks us to find, first of all, where these 2 equations intersect, to draw 2 tangents for those 2 points, and then find where those tangents intersect. So first of all, we're going to find where these 2 intersect. So we're going to set these equal to each other, as they both say y equals. I'm just going to do x squared equals x plus 2. And if I rearrange this, set it equal to 0, then I can actually factor this quite easily. And therefore, I can give you the 2 x coordinates of where these intersect. So x equals 2 and x equals negative 1. Now, if I'm going to do a tangent, I know I'm going to need a point and a slope. So I've got half half of the point here, so I just need to find the rest of it. So if I plug it back into y equals 2 squared is 4, you could plug it up here as well. 2 plus 2 is also 4. So there's one of my coordinates. And for -1, -1 squared is 1. Also -1 plus 2 is also 1, so it doesn't matter which one we go with. So I got my 2 points. Now I need to find my slopes at that point. So for y equals x squared, if I differentiate that, then dy by dx is just going to be 2x. Now I got 2 different ones to do for this one, so I just want to label very carefully what I'm doing here. So when x equals 2, dy by dx will equal 2 times 2, which is 4. And when x equals -1, the second point, 2 times -1 is -2. Now remember what we've got for all these ones? We've also got an associated point, and we also have the slope now. So we should be able to write the equations of 2 tangents at this point. Just a little high there. There we go. So first of all, let's do the one when x equals 2. So we know that it goes through, let's just scroll back up a second, it goes through 2, 4, and it has a slope of